Welcome back to Iptables Mastery, Lesson 9, where we stop guessing and start measuring. My rule isn't working is probably the most spoken sentence in firewall land, and today we're going to answer it in about 30 seconds flat. The trick is opening 4 windows on the same packet: counters to see if the rule was hit, logs to see what the kernel thought, tcpdump for the raw wire, and conntrack for the state machine. Each one tells a slice of the truth. Read all 4, and the bug stops hiding. So here are those 4 windows laid out. Counters are your fastest signal. Every rule tracks packets and bytes, and a counter stuck at 0 tells you instantly the rule never fired. The log target is non-terminal, meaning it stamps the packet into the kernel ring buffer and keeps evaluating, so always add a prefix you can grep for. tcpdump sits upstream of iptables on the wire, which makes it the perfect referee between firewall and network. And conntrack shows you the state machine, because a new connection that never reaches established is almost always a reply path that's being silently dropped. Let's start with the cheapest window, counters. Run iptables-L with -v-n, and every rule shows you exactly how many packets and bytes it has matched since the counters were last reset. Look at that last rule. 0 packets, 0 bytes on the HTTPS, accept. That rule has never fired, not once, and that single observation collapses your search space. Either the match condition is wrong CIDR, wrong port, wrong interface, or something above it is eating the traffic first. A growing counter means the match works, and you can move on to asking whether the target did what you wanted. An outsized counter 10 times what you expected means your rule is too broad and catching traffic you never intended. Counters tell you if a rule fired but not which packets hit it. For that, we open the second window, log. The crucial property here is that log is non-terminal. The packet gets a kernel log entry written, then keeps walking the chain as if nothing happened. So you insert it right before your suspect rule with a grep-friendly prefix like drop SSH, and now dmesg gives you the full forensic record. Source, destination, protocol, ports, TCP flags. Same traffic, same outcome, just with breadcrumbs. Here's the mental model that ties everything together. 1 packet, 4 windows, each watching a different layer. tcpdump shows it on the wire before iptables touches it. Counters confirm which rule matched. Kern.log captures what iptables said about it. And conntrack reveals the state machine in motion. The diagnostic power is in where the trail goes cold. tcpdump sees it, but the counter stays at 0. Your match condition is wrong. Counter climbs, but nothing in kern.log. You forgot the log rule. Conntrack stuck on new. The reply path is blocked. Stop guessing. Read the layers. Now let's turn that mental model into a procedure. 5 questions, asked in this exact order, and by the 5th one, the bug has nowhere left to hide. Start with tcpdump. If the packet never arrives, it's a network problem, not yours. If it arrives, check the rules counter. Flat counter means your match is wrong. Counter climbing but no log line? An earlier rule grabbed it first. Conntrack empty? Something dropped it before tracking. And if conntrack's happy but the app is deaf, you're looking at input ordering, not a block. Walk it once, and 30 seconds replaces an hour of guessing. Here's something that trips people up constantly. tcpdump sits below IP tables in the kernel stack, hooked into the raw socket via BPF. That means it sees every packet that hits the wire, even the ones IP tables is about to drop. So if tcpdump shows the packet but your application never receives it, congratulations. You've just proven iptables is the culprit. No further questions needed. 2 caveats though. On multi-NIC hosts, use ini so you don't miss the interface. And remember that DNAT rewrites happen after tcpdump's view, so an inbound capture still shows the original destination. So let's step back and ask the obvious question. Why 4 tools instead of 1? Because each one watches a different layer, and a bug at one layer is genuinely invisible to the others. They don't overlap. They complement. The practical workflow is cost-ordered. Counters are free and always on, so check them first. Logs are cheap, but only if you've added a unique log-prefix. Otherwise, your drop SSH hits drown in every other drop on the box. Capture with tcpdump and inspect conntrack only when the mystery survives the cheaper tools. And that's exactly the cheat sheet on screen. 3 columns, 1 page, print it and tape it next to your monitor. Left column is counters. List with LVN, zero them with Z, so the next packet shows a clean delta. Middle column is logging. Always set a log-prefix, then follow it live with dmesg, WW, or journals tele, KF. Right column is the heavy artillery. tcpdump on a port. Conntrack, E for live state changes, and the raw table trace target when you genuinely need to watch one packet walk every chain. Time to put it to work. 3 drills all in your rollback VM. First, 8 minutes on counters. Fire some traffic run, LVN before and after, and watch the deltas tell you exactly which rule matched. Second, wire up a log rule on port 22 with a prefix and tail dmesg in another window. That's your real-time packet feed. Third, the tricky one. Build a rule that looks correct but never fires. Telnet to a closed port and discover the counter stays 0 because the kernel RSTs the SYN before iptables ever sees it. Counter 0 doesn't always mean broken rule. Sometimes the packet simply isn't there. That last drill is actually the perfect lead-in to this slide. 5 traps that look like bugs but aren't. Log without a prefix. Your hits drown in kernel noise. tcpdump shows the packet, but the app doesn't see it. That's iptables dropping between the wire and the socket, not a network problem. A 0 counter might just mean no traffic ever arrived. Stale counts from yesterday's test will lie to you, so habit the Z before every reproduction. And on a busy chain, an unlimited log will flood the ring buffer and overwrite the very evidence you needed. Always rate limit it. So that's the whole toolkit. 4 windows, 1 answer. Counters tell you if a rule fired, log with a prefix tells you which packet, tcpdump tells you what hit the wire, and conntrack tells you what state the kernel thinks it's in. Open them side by side and "my rule isn't working" becomes a 30-second diagnosis. Next up, Lesson 10. Iptables, the successor. Same kernel, new syntax. See you there.